So let me first point out, in case you haven't already noticed, that weather is complicated. Weather actually, meteorologists can't forecast the weather without looking at the three dimensions of the atmosphere. And I'm not making excuses for when they get things wrong, but you know. So I want to focus, I think I've mentioned this term earlier, on what we call these upper level winds, called geostrophic winds. And in order to let me say that what I want you to know, and I'm going to kind of describe why they occur, but what I want you to know is that geostrophic winds are an upper level wind that basically come from the west and go to the east. So what you're looking at here, I don't know if you can kind of make it out. Let me kind of zoom in. What you're looking at here is a map of North America. That's the one I care about right now, and there's South America down there. And so here we have north, south, east, and west. And again, what I want you to know is that, I don't know if you can see this wind right here, this vector, but geostrophic winds is a westerly wind. And it's an upper level wind. And you know, it seems like a little it seems like I lied to you earlier when I said we have surface winds associated with the Hadley cell that are easterly trades, associated with the Ferrel cell that are mid-latitude westerlies, associated with the polar cell that are polar easterlies. I didn't lie. Okay, those are surface winds, but this is an upper level wind, a prevailing wind. And actually, coming up, I'm going to talk about something called Rossby waves, and actually sometimes there's kind of usually a gentle kind of kink in this westerly wave that kind of has a little bit of a, well, you can see the wave in it. But now to try to explain a little bit why we have at upper elevations, and you'll say, well, what is upper? And I guess I would say, or where do we begin this sort of, instead of kind of swirls that we see down at the Earth's surface, because we know that we have kind of swirly winds at the Earth's surface. When does it turn kind of straight a westerly wind? Well, there are maps to kind of show you layer by layer what the wind is doing. So I guess I would refer you to those. But I need to kind of revisit what's happening at the poles in order to kind of explain why we have this, at upper elevations, this westerly wind. Remember we said, and I'm going to kind of try to get to the surface here, I don't know if you can see me, we said that at the surface near the poles it's cold. I'm going to put cold down there, okay? That makes sense, right? Now, we said that at the Earth's surface, that creates a high pressure, and it does, because cold air is more dense, so it is a high pressure down there. Okay, but can you see, and I'm going to kind of focus in at the poles here, so I'm just kind of try to go three-dimensional on you. That air that at the poles that is kind of is a high pressure at the Earth's surface. Can you see where, as that air has settled, it created a low pressure aloft? Okay, so we have a high pressure at the Earth's surface near the poles, but we have a low pressure aloft. Okay, now I'm going to do something similar over here at the equator. Now this isn't, maybe this is the equator. So down here at the equator, near the equator, we have hot temperatures. Okay, and one of the things we know about hot temperatures is the air is kind of fluffy, and we have a generally, at the Earth's surface anyway, kind of a low pressure. We talked about that before with regard to surface winds. But what that does then is this sparse hot air, it ascends. Well, we know we have intertropical convergence zone there, don't we? So at upper elevations, what we have is, relatively speaking, a high pressure. Okay, so now I want you to switch gears and kind of think aloft. And when I'm talking aloft here, I'm talking about basically bumping up at the top of the troposphere, so bumping up against the tropopause. This geostrophic wind is strongest at the top of the troposphere. It's strongest. It gets stronger and stronger and stronger away from the Earth's surface. It peaks at the tropopause, and then entering the stratosphere, this geostrophic wind lessens, and that's because this pressure gradient that I'm describing aloft gets weaker. So let's look at aloft. Okay, we said up here at the poles we have at upper elevations, a general low pressure, even though at the surface we have a high pressure. And here aloft near the equator we have a high pressure aloft, even though we have a low pressure below. So let's look at the theme of what is the direction that wind will flow. And the theme is it will flow according to the pressure gradient, the change in pressure from high to low that's been created. So here we go. Here is our pressure gradient force right here at upper elevations. So now we need to go ahead and add in the Coriolis Force. The Coriolis Force, of course, sorry, that's funny. The Coriolis Force will deflect to the right in the northern hemisphere. So that's why, dun dun dun, this is our geostrophic wind. Geostrophic wind. Okay, up here. It's a westerly wind. And there you go. Okay, so at upper elevations, the wind is always westerly. I didn't lie to you, though, with regard to the surface winds associated with the three cells. So for those of you who are kind of filling in your PowerPoint slides, I'll give you a chance to kind of take a look at these words here on this slide. It's kind of what I mentioned on the other slide, but here we have that same figure, and I want to take one more look at this figure. And again, I just am amazed that we get any forecast right, because I'm sort of kidding, but I mean, it is so complicated. Can you see the 3 dimensions here with regard to, and this is simplified. I mean, this is an idealized situation. So again, we see at upper elevations, we have, generally speaking, kind of a low pressure here, at upper latitudes, and a high pressure here. And you can kind of almost see that. We've talked about the intertropical convergence zone. We have that air moving up, so it does get kind of high up here, even though it's a low down here. Ugh. And so then at upper elevations, we have pressure gradient force from high to low, indicated there, and deflection is to the right, so that is your upper level westerly wind, geostrophic wind.